Welcome to the session. I am Priyanka Udge, Assistant Professor, Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Today session is on block diagram reduction example. These are the learning outcomes. At the end of this session, student will able to reduce the block diagram using reduction rule, evaluate the transfer function of the system using reduction rule. These are the contents: block diagram reduction rule, procedure to reduce block diagram, example, advantages and disadvantages. Just take a pause and recall the transformation rules for block diagram reduction. Yes, these are the different transformation rules. Total 10 rules are there. So from that, number 1 rule, combining blocks in cascade. So here, if two blocks are connected in cascade or in series, just like G1 and G2, so its equivalent diagram is equal to G1 into G2. So both the blocks get multiplied here. Second rule, combining blocks in parallel. Now if two blocks are connected in parallel, G1 and G2 like this, here these two blocks get added or subtracted depending on the sign. If here plus sign is there, so here G1 plus G2 is there. If here minus sign is there, G1 minus G2 is there. Third rule, moving a summing point after a block. Now there is a summing point in block diagram. If we want to move this summing point after this block G, then we have to add the G block in this signal. So this is the equivalent diagram for shifting a summing point after a block. Similarly, when we shift summing point ahead a block, so if this summing point we have to shift ahead of this block, then we have to add the reciprocal of the block from which we have to shift the summing point. Next rule is moving a takeoff point after a block. So here you can see that takeoff point is there and we have to move this takeoff point after the block. So for that we have to add the reciprocal of this block, that is 1 by G here. The next rule, moving a takeoff point ahead of a block. Now here we have to move this takeoff point ahead of this block, G block. So at that time we have to add a G to this signal. Okay, so this is the equivalent diagram. The next rule is eliminating a feedback loop. In the eliminating feedback loop, there is one summing point, takeoff point, one transfer function is there in forward path and in feedback path. So this can be converted into equivalent diagram like G upon 1 minus plus GH. Here plus minus sign is there. So if plus is there, we have to take here minus, and if minus is there, we have to take the plus. So this closed loop, feedback loop can be converted into a single block with a G1 minus plus GH. Next, that is procedure for block diagram reduction. Now there are different steps. First, step number 1, we have to reduce the blocks connected in series. Step second, we have to reduce the block which are connected in parallel. Third step, reduce the minor internal feedback loop in which G and H is there. Fourth number step, as far as possible, try to shift takeoff point towards the right side and summing point to the left one. The step number 5, repeat step 1 to 4 till simple form is obtained. And step number 6, we have to calculate the transfer function of the closed loop system, that is C of S upon R of S. This is the example for block diagram reduction rule. So we have to consider this block diagram and we have to simplify it with the help of the block diagram reduction rule. First, observe this block diagram. The first step, that which blocks are connected in series, which blocks are connected in parallel and which blocks are forming a minor feedback loop. So here we can see that this G1 and G2, these two blocks are connected in series, and here G3 and G4, these two blocks are connected in parallel. Here plus sign is there, so we can add these two blocks. So step 1, here we have used the rule 1 for blocks G1 and G2. So here G1, G2 gets multiplied. Use rule 2 here for the blocks which are connected in parallel. So here we have converted it G3 plus G4. So this is the modified block diagram. Now from this block diagram we can say that G1, G2 and this H1, it will form a minor feedback loop. Okay, and this takeoff point, if we shift after the G5 block, then these two become in series and then we can apply the minor feedback loop. So step 2, we have to use here rule 3 for the blocks G1, G2 and H1, and here we will get this block G1, G2 upon 1 plus G1, G2, H1. Similarly, here we have used the rule 4 for shifting takeoff point after the block G5. So here we have added 1 by G5 transfer function. So that gets multiplied with this H2. So we will get this block H2 upon G5. So this is the simplified diagram. Now here these two blocks are connected in series. Okay. So first we will multiply this two block and then we'll form the feedback loop here. Here minus sign is there, so while taking the minor feedback loop we have to consider the plus sign. Step 3, use rule 1 for block G3 plus G4 and G5. Here we have multiplied that both the blocks which are connected in cascade or series. Okay. So this is the modified block diagram. Now here it forms a minor feedback loop. Okay. Step 4, here use rule 3 for blocks G3 plus G4, G5 and H3. Okay. So the modified block will be like this, G3 plus G4 into G5 and upon 1 plus this complete G multiplied by H3. Okay. So this is the simplified diagram. Now if we observe this block diagram, we can see that these two blocks are connected in cascade and in series. So these two blocks get multiplied and then it will form a minor feedback loop with this H2 G5. Here step 5. Here we have to use the rule 1 for the blocks connected in series. So this is our simplified block and this is the modified block diagram. Now here we can see that this block is in feedback with this H2 G5. So we can apply a minor feedback loop here. So step 6, last step. Here we have to use the rule 3 for the blocks connected in feedback loop. So we will get the modified block diagram as shown in the figure. So this is the simplified block diagram. So from this we have a one single block with a transfer function. So here y of s upon r of s is equal to this complete transfer function. So we can get the transfer function by using the block diagram reduction rule. These are the advantages. Number 1, it is very simple to construct for complicated system. The function of the individual element can be visualized. The individual and overall performance of the system can be studied by taking the transfer function. By using the different reduction rule, we can have the transfer function. So we can calculate the overall performance of the system. Overall closed loop transfer function can be easily calculated by using the block diagram reduction rule. These are the advantages. Block diagram does not include any information about the physical construction of the system. So we can't say that block diagram is exactly a replica of the physical construction of the system. Second one, Source of energy is generally not shown in the block diagram. So, number of different block diagram can be drawn from the physical system. These are the references. Thank you.